Now let's code our CNN, and in order to do so, we start always with renaming our file, which we call it main. Now what we will do is we also, as usual, we will import the needed libraries. So we start by import matplotlib.pyplot, and this is of course for plotting, and import seaborn as SNS also for plotting. Now the library we're going to use is TensorFlow, which is built on top of Keras. This is our deep learning library we'll use. So we will import Keras, and from Keras.models we import sequential, and this is we will define the model as sequential, in which we will add layer by layer on it. And from also Keras dot layers we import dense, which is used for fully connected layers, to build fully connected layers, and conv 2D, which is convolution 2D, and max pooling, also 2D, and flatten, and lastly drop out. So these are basically the methods we talked about in the previous class. We just import them, and then from Keras.optimizers we import Adam optimizer, which is simply an optimization algorithm. From Keras.layers we import patch normalization, and import CV2, which is where if we might not use it, but it's basically to handle images. OpenCV is still one of the very strong libraries. We import OS, operating system, if to handle the files, and NumPy as NP. Of course, we always know NumPy. Now there are another one in my system. I needed to add this to avoid error. So this is simply, in my system, I needed this library to make Keras and TensorFlow works. In your case, you might not need to do it. If you need to do something like this, you have to be careful regarding the compatibility between Keras, your Python version. In my case is 3.9, and Keras is a little bit old, so I had to have this library, and of course TensorFlow. So we have to be careful with these things. So it's better to based on your Python version, you need to install the right TensorFlow and Keras to make it run smoothly. So once we have done this, we simply shift enter, and now it's loading the libraries. So after that, because usually in deep learning it's a heavy computations like a problem. So for that we need to use many times a GPU. In my case, I have a GPU. I'm not running on desktop. I'm running on a laptop, However, I have a gaming laptop, so it has one GPU with 4 gigabyte of VRAM, so it's okay, it's good. So we will write here a statement to see our system, how many GPUs it has, and so on. Now we have here a problem. We look at it. Dense, I think capital letter. Yeah, capital letter. TF. Heavier. This is, yeah. Now it's working. So we need to print number of GPUs, and we have to, it will of course check the list config dot list, also from this library. Physical devices and GPU. So I think, okay. So number of GPUs I have is 1. So now what I will do is, I want the computation not to happen on GPU. I want the computation to happen on CPU. So what I will do is to write some to actually tell the computer that I want this computation to happen on GPU. Dot v1 dot session. It's simply a syntax we write. Of course, in your case, it might be different if you didn't have, or if it found the GPU, or you might need another library, but this is, you can try this one. Log device place sessions. So now it's processing. Yeah. So I have now connected my computer GPU. This is my GPU, NVIDIA GeForce RTX 3050 Ti laptop GPU. So this is my my GPU. Of course, there are many ways to do it, but yeah, I do this way, and for Keras, and there are many libraries in our in general, like for deep neural networks. So this is only for Keras, which is kind of the easiest way to build neural networks, but there are other libraries, like you need to build, for example, directly into TensorFlow, or you need to build onto Torch, and so on. So this is just my OS directory. The data we have is we need to detect the cracks, if the image has a crack or doesn't have a crack. This is our of course our purpose in this program is to build the CNN. However, what we need to do is we need to classify, or the actual problem we'll do is to classify if the image has a crack or not. To do so, what we will do is we will have the data. So in the data you have in the file, in the resource of this lecture, what you will have is you will have this compressed file, and with this compressed file you need to decompress it, and you will get these two folders that has these datas, and negative will have images that doesn't have any that doesn't have a crack. So you can, it's somehow stopped. So these images that doesn't have crack, and some images will have in the negative, we don't have here, the negative is no cracks, and positive is images which has a crack. And the purpose of our network is to tell us if there is a crack or there is no crack, or if or there is no crack in the image itself, and that's it. It doesn't have to tell us where is the crack is located. It simply needs to tell us if we have or if we don't have a crack. So yeah, so basically the first thing we need to do is we need to read the images, and in our case is we define for example, we call it read images, and here we have we need to pass labels and image size, and labels is basically in our case is negative and positive, is the location of the data. You can just call it also. And here what we will do is we will have the data to be nothing, and the thing what we will do, we will collect these datas, and then we will pre-process them in order to add them into the network as an NumPy array. To do so, we will start with an empty data, and we start putting the datas into, or putting these images into this file. So here data equals nothing, and then for label, in labels, in our case we have two classes, so it will be two here. Path is equal label, and then I mean you can print the path class number equals labels dot index label. Also you can have a counter here above, and you just put I equals 0, and you can increase it if you want. It doesn't have to use this just kind of indexing for the how many labels we have, because we will pass a list here for image in os dot list directory of path. So here it will go to this path, and then it will make the a list of the images located in this path, and then it will have this list with many images, IDs or locations, and we can take these images and work with them. Now we will use try except here because some images might have a problem, and this is also very good practice, because we're dealing with thousands of images. In this case we're dealing with 40,000 images, and 20,000 negative, 20,000 positive, or with crack. So it's better to use try and except, because it might not be, some images might be corrupted and not working. It's better to make the computer check it rather than yourself. Okay, so CV2 image read, and we take this path dot join between path, which is here our path, and the image name. Of course, this is a syntax, also a common syntax to check every or to read every image in a file. So it's very needed. So here path image cv2 that image read grayscale. In this case, we will not have a three input, or this is 3 channels, red, green, blue. We'll just read one channel. It's enough for our for this case, because if we put 3 channels, that means more processing requirement. Yeah, but for this classification, it's very a grayscale is very is enough for this example. So here we resized. Now we need to resize these images because we have all these images has to be in the same size. And here we have image size and image size because we will make it square. Of course, you don't have to make it square, but in our case, we will do that. So image size, and here data. After we read the image, we resize the image, we append the data, and here we will append the image itself and the class, which class it belongs to, class number here. Now this is if everything goes well. If everything didn't go well, just print maybe bad image found. Of course, you can just maybe also write the image name, this one. And with that, I think is done. We return, yep, we make the for loop, and after that we return the data as numpy array, the data. So this way we already made the function. Now what we will do is we will call the function. So we need to pass the labels and the image size as we have here. And the labels is in my system. I will just copy paste them because it's my location. It's simply like in my case, I just took the location of our specific file and the name of the folder, surface crack detection. It's more like this problem is classification other than detection, but anyway, it's called detection. And here the file is negative and one file is positive, and this is the labels. Now image size is going to be 120 pixels, which is small but not that small. Data set equals, just we pass on these, image size and labels, and when we press shift and enter, image size is not defined. Image, this one. Labels, I'm here. This is 6 label here. Label. This is labels is not defined. Labels.index. Okay, now it's reading. It's just here we have like this labels.index, which index of this. So it's syntax error, or like just writing error. So now what is doing is it will go for every image, and then it will read it and upload it into the as a data. We will continue. So what we and as it's doing this, it's about to finish. Anyway, what we will do is we will have, again, because we are doing a neural networks, we will always have X and Y. The X is the input, which is in our case images, and the Y is the labels. What is it? Is it a crack or not a crack in this case? So for features and label in data set, this one. Now this part is the pre-processing part. We are now creating the data that will actually go to the neural networks. So feature label in data set, what we will do is X append the features and Y dot append the labels, basically. But it's not this label. Because every data set, as we said here, we have image and label corresponding to it. Here is the image array, and this is the class number, which is basically the class. Now, this way, we'll do some processes, and I will print, do some print outs, because I want you to understand how these the array is being handled. So here we are just appending the data, and now we will reshape it. So here is as simple as just append the data. Now what after that we need to do is we need to reshape it to have the what we call MP array of X, which is this one. We need to reshape it to -1, which is it will have the number of rows of the amount of data. So the size of it will be just simply how many number of data you have, how many images you have, and the other size is the how many rows you have, how many columns in one row you have, and another one is the image, again size. This is how many columns you have, and we're using only one channel, so we put number 1. So this one is you want to create this array that has the number of images, which is the full number of images, which is in our case like 20,000 or something. Image size is the image size, the x and the width and the height, and 1 is simply the channels, number of channels. This is why we put -1 here and 1 here. Now, after that, what we will do is we talked about normalization, which is x divided by 255, which is the maximum number of any image will have any color from 0 to 255, and y is mp dot array of y, as simple as this. Now we can of course run it, but I want to print this just to get more idea how this will work. So I plus equals 1 if I equals 3, we will break and we will print, not here, we will need to print the data here before reshape, and it will be here, and we will print it after reshape, and we will print it after normalization, and we run. Of course, this will run only 3 times. It didn't here, maybe something it ran, but there's some problem here. Array, I didn't write here. So how this things work. So let's go for before reshape. So here we put all the data, all the images we have, the whole 20,000 images we have, we put them into one array, and this is called the dataset array, and it's an NumPy array, is an MP array. So this dataset will have an NP array of just arrays. The arrays will have the first one is it will have a NumPy array, of course. It will have the first one is the row, every row of the image, and the other one, this one, will contain the like every row after a row after row after a row. So the first one is the first row with these columns and the values of between 0 to 255, and then here we will have the other row and the other row and so on, until you have the other image, which will be here, and then another image and so on. Now after reshaping it, it will reshape into one channel, which is this one. Every value will be surrounded by a kind of a list, and this one will be the first the first parentheses will be the first row, and this one will parentheses the first rows of the first image, and after this highlighted parentheses ends, it will finish, and this is one image. We'll start another one, and this one another image. All of them will be contained within this one, this parentheses. Now here the values is between 0 to 255. Now what will happen after we divide 255? We simply normalize it. We divide the value on 255, and this is how our array will look like. So we remove, sorry, not this one. We remove the y is, there's nothing in it. It's just simply 1 or 0, the corresponding which class is this. One is one class, either the negative or positive, and the other one is the other one. And here I just need to remove, comment out these things because we will not use it. And now we will rerun again. After that, we basically end. This is how we have these input values or input images, and once this finished, we have, for example, if you want to see x dot shape, this is, we have about 40,000 images, 120, 120, which is the width and the height, and one channel, and of course here all the images. This is all the images, and if you want to see, of course, why, it will be the same size, but we don't have except just one value. If you want to see it, you can just print, and y will have 0 or 1.